Hello students, welcome to tutorenglish.com. So we have start with unit number 4 of systems in mechanical engineering, right? Hope you have seen the previous videos. So in the next two videos, we will be talking about gears and gearboxes. Now the picture which I have shown here, it's a gear. Okay, so this is how a gear looks. I think we are familiar with this word, right? Now, first thing is, where does we find this element in an automobile? Okay, see, basically we are talking about transmission system. Okay, or you can say power transmission system. Now, what comes in this? See, where does power get produced? It get produced in a engine. Now, this power has to be transferred to what? To the wheels. Okay. Now, whatever elements are going to come in between this, it is going to form your transmission system. That means you are transmitting power from engine to the wheels. तो क्या क्या आता है इंजन के बाद क्लच आता है फिर गियर बॉक्स आता है देन प्रोपेलर शाफ्ट आता है देन डिफरेंशियल गियर बॉक्स आता है एंड देन through the axis of rear wheels the power is getting transferred to wheels. Okay, so all these element it constitute a transmission system. So in next two videos we will be talking about gears and gearboxes. Okay, so I hope you have understood the location of gearbox. Okay, so let us start with the video and let us learn about gearboxes. So for that we have to learn first how power transmission takes place basically. See, this is a picture of belt and pulley arrangement that everybody knows. See, what is this? This is your electric motor. This is what? Electric motor. This is what? This is a driving pulley. Okay. This is what? Belt. What is this? This is a driven pulley. So how power is getting transferred? See, from the motor, okay, the shaft of the motor is going to rotate. So the pulley is going to rotate. So belt rope, it is going to rotate and so the this pulley. Okay, so this is how power is getting transferred from electric motor to the output shaft. यहाँ पे आपका output shaft होगा. See, again I am telling you, this is first when you are going to switch on the electric motor. So shaft, output shaft of electric motor, it is going to get rotate. अभी ये जो पुली है ग्रीन कलर की, इट इज ऑन आउटपुट शाफ्ट ऑफ मोटर, तो ये पुली रोटेट होगी. अभी पुली पे क्या माउंट है? बेल्ट माउंट किया हुआ है. सो ये बेल्ट जो है इट इज गोइंग टू मूव लाइक दिस. ओके, नाउ दिस बेल्ट इट इज कमिंग ओवर दिस driven pulley. Okay, this driven pulley, is it right? So due to as this belt is going to move, so that's why this pulley it is going to get rotated. अभी ये pulley जो है it is going to be on one shaft, it is going to be mounted on the shaft, so this shaft is going to get rotated. So this is a power transmission takes place. Now, but what happens in if you are using a belt drive, if you are using a belt drive, the most common problem you have to face is slipping. क्या होता है? ये जो belt है, it get slip from this pulley. Slipping होता है, right? Second, if there are certain precision machine, for example, let's say watches. Okay, for example, watch जो आपके which we use to see the time, उसमें क्या है basically it's a उसमें भी it is an application of gears only. Okay, लेकिन वो जो गियर्स है those are very precise. So wherever such type of precision is required, we cannot use belt drive. We cannot use belt drive. Okay. Why? Because as slipping takes place, that means it is not a positive drive. This belt drive, it is not a positive drive. This thing you have to remember. So that's why gears, or these are also called as tooth wheels, are introduced, and which is what we are going to study. So I hope you have understood how power transmission takes place, first thing, and second, why belt drives are not used in precise machine. Okay, the reason is it causes slipping. Right, there are chances of slipping of belt from the pulley. Okay, right. So to avoid this slipping or to get a positive drive, we are going to use a gears. Now these gears can be considered as a tooth wheel. Okay, okay. So let us see first figure number A. It's a friction wheel. Okay, so there is one disc A which is mounted on the shaft. This is your shaft. Okay, let's say this is shaft number 1 and this is your shaft number 2. So let's say the shaft 1. See, मैं यहाँ पे एक ब्लॉक डायग्राम निकाल दूँ. Let's say this is a motor. इसका एक आउटपुट शाफ्ट होगा. ये शाफ्ट पे let's say एक डिस्क यहाँ पे माउंट की हुई है. This is a disc. Okay, so this disc, that means let's say this is A. So this disk A, it is in contact with disk B. So this is my disk B. Okay, and this disk, again it is mounted on the shaft number 2. So this is my shaft number 2. Okay, so this is what shaft 1, this is what shaft number 2. अभी कैसे पावर ट्रांसमिशन होने वाला है वो देखते हैं. when you are going to switch on the motor, क्या होगा, ये शाफ्ट रोटेट होगा, तो ये जो डिस्क है वो भी क्या होने वाली है, रोटेट होने वाली है. लेट्स से दिस डिस्क इट इज मूविंग इन clockwise direction. Okay, so this disc, as it is in contact with disc B, it is going to apply a tangential force P on friction disc B. Okay, so that's why this is what a tangential force is shown here. Okay, is it clear? Right. That means it is going to force this disc B to rotate. So that's why this disc B, it is going to rotate in counterclockwise direction. Now this disc B, it is mounted on shaft number 2. So that's why this shaft is also going to get rotated. So this is how the motion it is getting transferred from motor to disc A to disc B and then to shaft number 2. Is it clear? Okay. Now, as long as the next statement is very important, as long as this P it is less than or equal to frictional force. Of course there will be friction, those are called as frictional wheels. यहाँ पे contact है, कोई भी दो चीजें, if any two things are in contact, obviously there is going to be a friction between them, so frictional force will be there. So as long as this P it is less than or equal to F, you can go with this setup, there is no problem. But when P exceeds frictional force F, it causes slipping. Okay, that's why we have to go for another arrangement. That means now this is what, this is a plain disc. Now I am producing a teeth on the periphery of disc A and I am producing the teeth on periphery of disc B. so that whenever they are going to be in contact with each other, there will be meshing of the teeth. There will be meshing of teeth. Okay, that means the these are nothing but a projection or teeth. That means teeth which are on periphery of A, they are going to fit into the corresponding recesses on the periphery of B. Okay, see, this is your teeth, teeth of A. Now, where it is getting fit, it is getting fit into the recess. This is the recess. यहाँ पे क्या है, free space है. So it is getting fit. Where it is getting fit? It is getting fit into the recess of D. Okay. So this is how. Now, if you are using this such type of arrangement, if you are using such type of arrangement, then the sleeping can be avoided. Sleeping can be avoided. Okay. So these are what? Tooth wheels are nothing but these are also called as gears. These are also called as gears. Okay, now let us see what are the advantages of using such type of arrangement. So, advantages of gear drive. So, basically, what are gears? Gears are nothing but tooth wheel which are used for power transmission. This is the definition of gear. Okay, see, you can check here. So this is the direction of power, how power is getting flow from one shaft, then to the gear 1, then to the gear 2. This gear 2, it is mounted on this shaft. So this is the output. So basically this is the input side, this is the output side. So this is how the power is getting flow, power flow you can say. Okay, so what are the advantages of using gear? First thing, it's a positive drive, no slipping, high efficiency, those are reliable, compact. When you are using belt, rope, and pulley arrangement, space requirement is more. But for gears, it requires lesser space and speed variation is possible. Okay. Now, what are the disadvantages of gear drive? First is manufacturing cost is more as compared to belt drives. Manufacturing is difficult. Special tools are required. Special machines are required. Special tools and equipments are required. Then again, maintenance. You have to do oiling and all those things. Okay, so maintenance, because there is a lot of frictional things are there. So maintenance is required, and cutting teeth, it has to be precise, then only it is going to give you desired output. So these are some advantages and disadvantages of gears. Okay, so I hope for till now we have understood what are gears, how gears looks, why we are switching from belt rope to gears, right? And third thing is advantages and disadvantages of gears. So MCQs are possible. So please note down all the important things, right? Okay. And one more thing, I hope you have understood how the power transmission is taking place. Okay. So if I have to show here, let's say this is the input shaft. Let's say this is a gear 1, which is in mesh with gear 2, and this is your output shaft. So कैसे हो रहा है पावर ट्रांसमिशन, कैसे हो रहा है फ्रॉम इनपुट शाफ्ट. सो इनपुट शाफ्ट पे क्या है, गियर 1 है. अगर इनपुट शाफ्ट रोटेट हो रहा है तो गियर भी रोटेट होगा. फ्रॉम गियर 1 पावर इज गेटिंग ट्रांसफर टू गियर 2. Okay, and gear 2, it is mounted on the output shaft. It is mounted on the output shaft, output shaft. So this is how the flow of power it is taking place. Okay, so this is how the flow of power is taking place. So I hope you have understood how the power transmission takes place, right? Okay. Now there are different types of gears. Let us do, or let us see classification of gears. Now the first classification, this can be classified in number of ways. So first classification is according to the position of axis of shaft. हमने पिछले एग्जाम्पल में भी देखा था कि जो गियर है it is mounted on the shaft, it is placed, you can say placed on the shaft. Okay, for example, this is one gear, so you can see here on the shaft it is going to be placed using key. यहाँ पे आपको एक स्लॉट दिख रहा है. ओके यहाँ पे भी एक स्लॉट है. ये स्लॉट किसके लिए? इट इज फॉर की. So this is also one element. Okay, so we are not going to study that. So just remember gears are mounted on the shaft. So gears are used to connect maybe parallel shaft, intersecting shaft. That part we are going to see. Okay. So first thing is, if you want to transmit a power between two parallel and coplanar shaft, two parallel and coplanar shaft, then you can go with first spur gears. So this is how the spur gear looks. Now what is the specialty of this? Now if you look at the teeth, these are the teeth. Okay, let me use another color. These are the teeth. So these teeth are cut parallel to the shaft. Is it right? Here also, these teeth are cut parallel to the shaft. That's why these are called as spur gears. Such type of gears are called as spur gears. Okay. Now you have to remember some point. Spur gears, these are easy to manufacture. Okay. So it is going to connect a parallel shaft. That is one thing. So these are less expensive. These are less expensive. Okay. Efficiency is good, no problem. Efficiency is good, around 95%. So for high speed application you can use this, but a major issue with this spur gear is these are noisy in operation. So please remember this thing. These are noisy in operation. Okay. Now the second type of gear which you can use to connect a parallel shaft, these are called as helical gears. Helical gears. Now, if you look at the teeth, these teeth are cut at, these are not parallel, those are at an angle. Those are cut at an angle of the shaft. Okay, so such type of gears are called as helical gears. Okay, now major advantage of helical gear is these are smooth and quiet in operation. Okay, we have seen spur gears, those were noisy, so that disadvantage can be removed. If you want, if you are going to use the gears in the application where noise is not required, so you can choose helical gears. Then efficiency, it is high as compared to spur gear, around 98%. These are difficult to manufacture because you have to cut the teeth at an angle. So these are difficult to manufacture. And of course, these are going to be more expensive. So please remember what are the differences between spur and helical gears. Again, we will revise this. Spur gears and helical gears both are used to connect a parallel shafts only. But in case of spur gear, teeth are cut parallel to the axis of shaft, where in case of helical gears, teeth are cut at an angle to the axis of shaft. Okay. Second, spur gears, these are less expensive and easy to manufacture as compared to helical gears. Efficiency of spur gear, if you are going to compare these two, efficiency of helical gear is more. And major thing you have to remember that spur gears are noisy in operation as compared to helical gears. Okay, right. Now, one more important point you have to remember here is what are herringbone gears? What are herringbone gears? So these are basically double helical gears. Okay, so this is more than enough. These are basically double helical gears. Okay, right. Let us see the next type. I hope please note down all these important points. Okay, you will find MCQ based on these points only. Okay, this is more than enough for first year engineering. Now, if the shafts are non-parallel or intersecting shaft, then we are going to use bevel gears. We are going to use bevel gears. Okay, so basically for transmitting a motion between two intersecting shafts, bevel gears are used. Obviously, these are going to be difficult to manufacture, okay, because you can see how the teeth are cut. Okay, they are almost at a desired angle. Okay, it is at an angle, you can say curve. It's a teeth curve teeth profile. Okay, right. So obviously these are going to be difficult to manufacture and these are going to be expensive. Okay, but there are certain advantages, like it can transmit a power between intersecting shaft, while spur and helical gears we cannot use. Then bevel gears, these are available in various sizes as per the requirement. Okay, then if you compare this with spur and helical gear, it require less space. Okay, so that is the advantage. Efficiency is also higher. Okay, and these are not noisy. These are not noisy. Okay, so these are certain advantages and disadvantages of bevel gears. So please remember with the picture, sometimes they will give such type of picture and they will ask you to identify the type of gears. So that's why I have purposefully I have put all these pictures, right? Okay, now let us see the next type. Now if the shafts are non-intersecting but perpendicular. Okay, this is what, this is the axis, this is the axis of the shaft. Okay, like this, and the axis of this, it is like this, axis of this gear. Okay, like this. They are non-intersecting but they are perpendicular. They are what? Perpendicular. Okay, so if you want to transmit a power between two non-intersecting but perpendicular shaft, then the gears which we are going to use are called as worm gears. So these are worm gears. So the smaller one, it is called as worm. The bigger one, it is called as worm wheel. Is it clear? Or sometime it is called as wheel or worm gear. Okay. So, okay, one thing I have forgot. Application of bevel gear is very important. So bevel gears, please note down this point. Bevel gears, these are used in differential gearbox. Please note down this differential gearbox. Okay, so which is element of power transmitting system. That's why the application is very important of bevel gears. These are used in differential gearbox. Okay, so I hope you have written this right. Now, what are the advantages, disadvantages of worm gears? So efficiency is okay, it is less. Okay. Now during operation basically more heat is generated, hence effective cooling is required. Okay, effective cooling is required due to more heat generation. Of course, these are more expensive out of all the 3 to 4 types which I have seen, and of course, manufacturing is difficult. Manufacturing is difficult. Okay, now the major point which you have to remember in case of worm gears, these are self locking or these are called as non reversible. Okay, right. Now, why it is called as self locking or non reversible? Now, here worm it always acts as a driver, while worm wheel it always acts as a driven mover. Okay, how the power is going to flow? This is how a power is going to flow. It will never go like this. That is from worm gear to worm. No, only one way power transmission is possible. One way power transmission is possible. That's why these are called as self-locking or non-reversible. So due to this property, which see you will not find this property in another type of gears, spur gears or helical gears or bevel gears. In both the direction power transmission is possible. But in case of worm gears, you have to remember those are called as non-reversible or self-locking gears. Due to this property, this is major application you will find in cranes, in hoist, lifts, major application in lifts, okay, as well as these are used in kita. सेल्फ लॉगिंग फॉर एग्जांपल क्रेन है, हमने लेट से आपने कोई एक हेवी चीज आपने क्रेन से उठाई है, ऑब्वियसली ऑटोमेटिकली इट शुड गेट लॉक, राइट? अगर वो वापस गिर गई इट इज गोइंग टू बी हजार्डस. सो दैट्स व्हाई once any product, once we have lift, it should get locked there. So that's why in cranes, hoist, lift, worm gears are used. Okay, right. So please note down all these are all important points. What are the application, advantages, disadvantages, and also the picture is very important. So major point you have to remember is it's a self-locking. So if you are new to my YouTube channel, please do like and subscribe. And if you're liking these videos, don't forget to share with your friends and please write in the comment box whether you are finding these videos useful or not. So we have seen according to the arrangement of shaft. Now according to the type of gearing, so this is what? This is external gearing. Okay, that means gears are meshed externally. While in the second picture, this is a picture of internal gearing. Gears are meshed internal. Okay, so external gears and internal gears. Now, the gear terminology. Now, this part is very important. Please note down all the important points. Right. So, I have shown here a picture of gear. Okay. Now, these are the tip. So, you can count the number of tip. Is it right? So, let's say number of teeth on the gear, let's say it is capital T. You can count actually. Okay, right. Now let's say this is the center. From center to the extreme point, so basically the circle which is passing through That means the circle which I am drawing here. So from the top of the teeth, this is called as addendum circle. Addendum. Addendum circle. Now circle which is passing from the base of the tooth. This is called as dedendum circle. Dedendum circle. So I am going to define one more diameter, which is an imaginary diameter. Let's say it is between addendum and dedendum. That imaginary diameter of gear, it is called as pitch circle diameter. Okay, it's an imaginary, right? You can draw addendum, you can draw the dedendum, pitch circle you have to consider, right? So I can define new terminology, that is the module, which is denoted by M, which is equal to diameter of the gear to the number of teeth. Please remember this formula. What is module? Okay. Now, if there are two gears which are in mesh, for meshing, for meshing of gears, for meshing of gears, that means there will be one meshing means what, यहाँ पे एक और एक गियर आएगा. Okay, so meshing means, see, gears in a single, gears always exist in pair. Okay, सिर्फ सिंगल गियर कुछ काम का नहीं है, उसके साथ और एक गियर चाहिए सो दैट यू कैन ट्रांसमिट द पावर. अगर एक अकेला गियर है यू कैन नॉट ट्रांसमिट द पावर फ्रॉम दैट. Okay, to transmit the power you should have a pair of gears. Okay, so for the meshing of gears, module must be same. मॉड्यूल मस्ट बी सेम. मॉड्यूल कैसे कैलकुलेट करते हैं, अभी हमने देखा है पिच सर्कल डायमीटर टू द नंबर ऑफ टीथ. प्लीज रिमेंबर दिस. ओके, राइट. So this is one thing which I want to tell. So this is also useful while solving the examples. So please remember all the important points. Now come to this picture. So this is how power transmission takes place. Okay, so I'm giving now, this is what, this is the input shaft. Now the gear 1 is called as a pinion. This is a gear 2. This is termed as gear, and this is your output shaft. Okay, so how power transmission is taking place? This is how power transmission is taking place. Now these two gears are in mesh. This is the meaning of mesh. I have told you, to transmit the power you should have a pair of gears. And what is the important thing? The module of gear 1 and module of gear 2 must be same. Okay, diameter, number of teeth can be different, but module has to be same. Now, so let's say the diameter of the gear 1, it's a D1, and number of teeth is T1. Now, the pitch circle diameter, it is D2 of gear 2, and number of teeth are T2. Okay, you can count the number of teeth, no problem. So, gear ratio or velocity ratio is defined as input speed ratio, input speed divided by output speed. Okay, please observe carefully. These are all important points. Let's say this shaft, it is rotating with the speed n1 rpm. Or if you want to simplify this further, let's say dp, it is the pitch circle diameter of pinion, tp, number of teeth on the pinion. Okay, then dg, it is the pitch circle diameter of gear, and tg, it is a number of teeth on the gear, so that it will be easy for you. Okay, now n1, it is the speed with which input shaft is rotating, and the n2, it is the speed of the output shaft. So how you can write the gear ratio? कैसे लिख सकते हैं हम? This is equal to, what is the input speed? n1 divided by n2. Now, okay, n1 divided by n2. Now this pinion, it is mounted on input shaft. So and it is mounted means, देखो यहाँ पे कलर सेम बताया है. Okay, so that's why the speed of input shaft, the speed of pinion and speed of input shaft, it will be equal. So instead of n1, I am writing now np divided by. Now the gear, this is about pinion. Pinion is mounted on the input shaft. So pinion term हम कम use करेंगे. Here it denotes the gear which is mounted on input shaft. Okay. Now simply if it is a gear, we will talk that it is mounted on the output shaft. So n2, it will be ng. Okay. So let me write this as np, and let me call this as ng. Okay. All right. So this is what definition of gear ratio, np upon ng. Okay. Now there is one another way also to define the gear ratio, which is equal to diameter of gear to the diameter of pinion. Okay, now see, I have told you module of pinion is equal to module of gear. Now, how we define module? D upon T. So therefore, can I write this as dP upon Tp, which is equal to dg upon tg? So what will be dg upon dp? Yes, dg upon dp, which will be equal to dg upon dp. Therefore, what are the different formulas of gear ratio? Gear ratio, first formula in terms of speed, np upon ng, which is equal to, in terms of diameter, dg upon dp, in terms of number of teeth, tg upon t. So these are various formulas you have to remember in case of gear ratio. Okay, so this is very important formula. Based on this, we are going to solve a number of examples. Is it clear? Okay, right. Please note down, you can pause the video. Please note down everything. Okay, so all the things are very important. I hope you have understood the concept of gear ratio. So you can define gear ratio in terms of speed. So basically, this is what? This is in terms of speed. This is in terms of diameter. This is in terms of number of teeth. Remember all the three formulas. Now, let us see the simple examples on this. Those are very important. Okay. Now, read the example. The pinion with 120 mm pitch circle diameter. So, this is our pinion. What is the DP? 120 mm. It is in mesh with the gear of 400 mm pitch circle diameter. So what is DG? 400 mm. Now, number of teeth on the pinion, it is 18, and it rotates with 1440 rpm. 1440 rpm. Determine gear ratio, number of teeth on the gear, and speed of the gear. Number of teeth on the gear. Tg is equal to what? Speed of the gear. Ng is equal to what? And what is the gear ratio? Okay. So if you have understood all the previous formulas, gear ratio in terms of diameter, it is what? Dg upon dp. So what is dg? 400 divided by 120. So it will be around 3.33. Okay. Second, calculate now number of teeth on the gear. So what is gear ratio, which is 3.33 in terms of number of teeth? Tg upon tp. So tp we know 18. So tg, which is equal to 3.33 into tp, which is equal to 3.33 into 18. So approximately you will get it as 60. This is approximation. You have to round it off. Okay, हम point में तो टिक नहीं बना सकते. So you can round it off. So next is speed of the gear. So gear ratio in terms of speed now. Np upon Ng. So Ng, which is equal to Np upon gear ratio. What is Np? 1440 divided by 3.33. So approximately 430 rpm. Okay, so the previous slide was very important. If you remember all the terminologies, किसको pinion बोलते हैं, किसको gear बोलते हैं, number of teeth, diameter, module, you can easily solve any example. Okay, so I hope this example is clear. Now let us see the next example. Now a pinion of pitch circle diameter. So pinion of pitch circle diameter 150 mm. Okay. Now some may have the question. So ये फिगर हम एग्जाम में वगैरह कैसे बनाए? नहीं. देखो एग्जाम में आपको एमसीक्यू हो कुछ भी हो, आपको इस तरह से डायग्राम बनानी है. ओके, एक बार अच्छे से बनाते हैं. दिस इज दी एक्सिस. अब इसमें क्या क्या है वो देखते हैं. दिस इज दी इनपुट शाफ्ट. दिस इज इनपुट शाफ्ट. ओके, दिस इज योर पिनियन. दिस इज योर गियर एंड दिस इज योर आउटपुट शाफ्ट. ओके, इस तरफ से आपको डायग्राम बनाने हैं. यहाँ पे आप फिर जो भी दिया हुआ है वो लिख सकते हो. एंड वी नो व्हाट इज गियर रेशियो. बेस्ड ऑन दैट यू कैन सिंपली सॉल्व द एग्जांपल. राइट. ओके, let us see this example. The pitch circle diameter is 150 mm. Okay, pinion. So dp, it is 150 mm and it is having 80 teeth. Gear ratio is given. What is the gear ratio? It is 4. Speed of the gear, so Ng, it is given 500 rpm. Determine diameter of the gear. Dg निकालना है. Speed of the pinion, Np निकालना है. And number of teeth on the pinion. Number of teeth on the pinion क्या दिया था? ओके सॉरी, यहाँ पे क्या है? गियर हैविंग टीथ ऑफ 80. ओके, so we have done here one mistake. TP we have to find out and number of teeth on the gear it is given. So TG it is given as 80. Okay, so let us solve this. So gear ratio is given. So it is what? DG upon DP. So diameter of gear you can find out. Gear ratio into what is DP? 150. It is really 600 m. Very easy. Then gear ratio it is 4 in terms of speed now. Np upon Ng. Ng it is equal to what is Np? Np divided by 4. NP हमें फाइंड आउट करना है, NG दिया हुआ है. ओके, so NG it is equal to NP divided by 4. What is NP? Oh, we have done I think the same mistake. NG दिया हुआ है, so simply you have to multiply. कितना आएगा, यहाँ से NP निकालना है, 4 into NG. So 4 into NG is how much? 500. It will be 2000 RPM. Okay. Then the last thing we have to find out number of teeth on the pinion. क्या है gear ratio? 4 in terms of number of teeth. So TG upon TP. क्या फाइंड आउट करना है? TG दिया हुआ है. Okay, so TP is equal to TG divided by 4, 80 divided by 4. So TP, how much it will be? 20. Okay, right. So hope you are getting this example. These are very easy. Now this is a little bit different. Let us see. Example number 3. The pitch circle diameter of pinion is given. Pitch circle diameter of pinion dp it is 200 mm. Gear ratio is given. Gear ratio it is equal to 3. The pinion is attached to motor having 1440 rpm. We let's say here it is a motor. So here the shaft है. What is the speed? 1440 rpm. That means NP it is 1440 rpm. ओके, मैंने क्या बताया, ये शाफ्ट और ये जो पिनियन है इसका स्पीड क्या रहेगा, सेम रहेगा. नाउ दिस मोटर इट इज ऑफ 20 किलोवाट पावर. ये जो मोटर है इट इज ऑफ 20 किलोवाट पावर. नाउ नंबर ऑफ टीथ ऑन द पिनियन. सो ऑल द डेटा ऑफ पिनियन इज ऑन दिस गिवन. यू हैव टू फाइंड आउट व्हाट इज द टॉर्क रिक्वायर्ड टू ट्रांसमिट द पावर एट पिनियन. दैट मीन्स TP हमें फाइंड आउट करना है. ओके, दिस इज व्हाट टॉर्क बेसिकली. Okay, so we have to find out the torque at the pinion at this side. Torque at the pinion you have to find out, and number of teeth on the gear. So you have to find out T. Okay, right. So previously also we have seen the formula of power, torque into omega, torque into 2 pi n by 60. ओके, अगर एट द पिनियन पूछा है, पावर एट द पिनियन, तो आपको टॉर्क क्या लेना होगा? यू हैव टू टेक द टॉर्क एट द पिनियन इनटू ओमेगा ऑफ पिनियन. इफ दे आस्क यू द पावर व्हिच इज रिक्वायर्ड एट द गियर, सो यू हैव टू टेक द टॉर्क एट द गियर इनटू ओमेगा ऑफ गियर. यहाँ पे टी क्यों नहीं लिख रहा हूँ? बिकॉज यू मे गेट कंफ्यूज विथ नंबर ऑफ टीथ. सो ये फॉर्मूला में इट्स अ टॉर्क. दिस इज व्हाट टॉर्क. ओके, यहाँ पे नंबर ऑफ टीथ नहीं है. समटाइम्स नंबर ऑफ टीथ कैन बी डिनोट विथ z. राइट. ओके, तो अभी क्या पूछा है हमें? टॉर्क रिक्वायर्ड टू ट्रांसमिट अ पावर एट द पिनियन. सो हम ये फॉर्मूला यूज करेंगे ऑब्वियसली. राइट. सो लेट मी रब दिस फॉर्मूला. So what is the power here? 20 kilowatt. 20 into 10 to the power 3, which is equal to 2 pi into what is the speed? 1440 rpm, revolutions per minute. That's why we are taking this 60 into torque. So very easy, you can do the calculation. You will get torque at the pinion, it is around 133. Unit is Newton meter. Okay, unit is what? Newton meter. So this is the first answer. And second, gear ratio they have given you. So gear ratio, how we define? Number of teeth on the gear to the number of teeth on the pinion. क्या पूछा है? Number of teeth on the gear, TG, which is equal to what is the gear ratio? 3 into TP. What is TP? 20. So it is nothing but 60. So these are the two answers. Okay. So if you have understood the theory part, concept, gear terminologies, what is module, what is diameter, number of teeth, then this is a new formula, power, torque into omega. Okay, I have told you, if it is asked the at the pinion, take all the things related to pinion. Okay, NP, TP, right? If they have asked you about the gear, at the gear, you have to take the corresponding terminologies of gear, right? So such type of examples can be asked in the MCQ format also. Okay, they are not going to ask you all the three things, but definitely they will ask you calculate the number of teeth, calculate the or diameter, or calculate the module. Okay, so such type of simple question will be there, right? Or calculate the gear ratio. So please remember what is gear ratio. Definition of gear ratio in terms of speed, in terms of diameter, in terms of number of teeth. Right, so that is the most important point from this video. So hope you have understood. Okay, so hope you have understood the things which we have learned here. So let me collect all the things which we have seen. Let me note down everything so that it will be easy for you. Okay, so what things we have seen? First, what are the disadvantage of belt drive? क्या होता है डिसएडवांटेज बेल्ट ड्राइव का? यस, ट्राई टू रिकलेक्ट. It does not give you positive. Slipping is a major issue. So that's why concept of friction wheel, which we have extended to tooth wheel, we have seen. Okay, where slipping is not there, this is a positive drive. This is the positive drive, and tooth wheels are nothing but gears. Right? Then we have seen what are the advantage and disadvantages of gears. Very important. Then we have seen classification of gears. In the classification, we have talk of spur gears, we have talk of helical gears, we have talked about bevel gears, and worm and worm wheel. Okay, then the next part we have seen gear terminologies. In that, two are very important. So one is what is module, and second what is gear ratio. Gear ratio. And then we have seen examples which are very important. So these are all important things we have discussed in this video. So hope you have understood. These are very important. On the gears itself, you can expect at least 2 to 3 MCQs on gears and the gearbox. Okay, so hope you have understood all the things. Please, you can practice more examples. Okay, and I'm definitely sure you can. Applications of all these are important. Spur, helicals, I have told you the differences and the applications. Those are very important from MCQ point of view, and examples, gear terminologies, these 2 points are very important. So please hit the like button, and if you are new to my YouTube channel, please don't forget to subscribe, and also try to share with your friends so that this is a free course, they will also get benefited. I have already uploaded the MCQs on unit number 1, 2 and 3. You can go and watch all the previous videos, right? So I will try to put more videos. Now we will concentrate only on unit number 4 with MCQs, obviously, right? So that it is going to helpful for your exam point of view. Thank you everyone.